Good afternoon, everyone.
I am Christine Margito
I am Carsjoy Gidiwala.
I'm Reyna B. Gonzaga.
from Group 9.
So our topic is about angular momentum. Introduction. Angular momentum is a fundamental concept in physics that describes an object's rotational motion. It quantifies an object's tendency to continue rotating, much like linear momentum describes its tendency to continue moving in a straight line. We will explore its definition, key principles, and applications in this presentation. So, angular momentum. Angular momentum is the product of an object's amount of moment of inertia and its angular velocity. So, angular momentum is ma-calculate niya siya by multiplying its moment of inertia ug ang iyahang angular velocity. Angular momentum is a conserved quantity, meaning it remains constant unless an external torque acts upon the object. Next is angular velocity. Angular velocity, this simply means unsa ka paspas mutuyok ang isa ka object. So og higher ang iyahang angular velocity, mas paspas pud mutuyok ang isa ka object. Example kay kana bitaw katong patuyok-tuyok nga mura katong patuyok-tuyok na dulaan og paspas to siya mutuyok, meaning mas higher or mas dako ang iyahang angular velocity. Next is moment of inertia. This describes how difficult it is to change an object's rotation. So, ang moment of inertia kay ga-describe ni siya unsa ka lisod ma-change ang rotation sa isa ka object. Magdepende ni siya sa ug unsay mass sa object ug unsa pud gi-distribute ang mass. So og mas dako ang iyahang moment of inertia, meaning mas lisod siya start or stop ang pagtuyok sa isa ka object. Last is conservation of angular momentum. So kani nga principle nag-state if walay forces ang isa ka object, meaning ang iyang angular momentum is mag-remain constant. This explains why skaters spin faster when they pull their arms in. So by reducing their moment of inertia, mas dapat i-increase nila ang ilahang angular velocity para ma-keep gihapon og same ang iyahang angular momentum. So the total amount of spin stays the same but it's concentrated into a faster spin.
So formulas. Angular velocity formula. V is equal to WR, where V is the linear velocity and R is the radius. So moment of inertia formula. I is equal to 1/2 mr squared, where m is the mass and r is the radius. Angular momentum formula. So L is equal to IW, where L is angular momentum measured in kilogram meter squared per second, and I is the moment of inertia measured in kilogram meter per second meter squared. W is the angular velocity measured in radians per second radius per second.
Example number 1. Problem. A solid disk with a mass of 2 kg and a radius of 0.5 meter is rotating at a constant angular velocity of 10 radius per second. Calculate the angular momentum of the disk. So, calculate the moment of inertia. So, ato rang i-follow yung formula nga inertia equals 1/2 mass times radius squared. So, first atong kaon yang mass na 2 kg. Ato lang din na siyang tungaon, so mayon siya og 1/2. Dayon, radius 0.5 meter. So, ato lang dayon na silang i-time. So, therefore, ang iyang inertia is 0.25 kg meter squared. So, calculate the angular momentum. So, i-use ra gyud po nato yung formula nga angular momentum equals angular velocity times inertia. So, 0.25 kilogram meter squared times 10 radius per second. So, ang equal din niya is 2.5 kilogram meter squared per second. Example number 2. Problem. A thin rod of mass 0.8 kg and length 1.2 meters rotates about its center. If it rotates at a constant angular speed of 4 radians per second, what is its angular momentum? So, i-follow ra gyud po nato ang formula. So, inertia equals 1/2 mass times angular momentum squared. So, ang iyang mass is 0.8 kg times 1.2 meter. So, iya yung equals is 0.096 kilogram meter squared. Calculate the angular momentum. So, angular momentum times inertia times angular velocity. So, 0.096 kilogram meter squared times 4 radians per second. So, equal to 0.384 kilogram meter squared per second. Example number 3. Problem. A solid cylinder of mass 4 kg and radius 0.1 meter rolls without slipping down an incline. At the bottom of the incline, its linear velocity is 2 meter per second. What is its angular momentum of that point? Sige. Linear velocity equals angular velocity times radius. So, ang iyang linear velocity is 2 meter per second. Tapos, ang iya yung radius kay 0.1. So, imo lang dayon na siyang i-divide. So, may equal na din siya sa 20 radius per second. So, number 2, calculate the moment of inertia. So, inertia is equal to 1/2 mass times radius squared. So, ang iyang mass is 4 kg, tapos ang iyang radius is 0.1 meter. So, ang 1/2 man sa 4 kg kay 2, i-times lang dayon na nato siya sa 0.1 meter squared. So, may equal na din siya sa 0.02 kilogram meter squared. Number 3, calculate the angular momentum. So, angular momentum is equal to moment of inertia times angular velocity. So, equal siya sa 0.02 kilogram times 20 radius per second. So, may equal na din siya sa 0.4 kilogram meter squared per second. So, answer, the angular momentum of the rolling cylinder at the bottom of the incline is 0.4 kilogram meter squared per second.
Conclusions. In conclusion, angular momentum, a fundamental concept in physics, describes the rotational motion of objects. It's a vector quantity possessing both magnitude and direction, and is crucial for understanding diverse phenomena ranging from planetary orbits or subatomic particles. Its magnitude is determined by the product of moment of inertia and angular velocity, where L is equal to IW, with a moment of inertia reflecting an object resistant to rotational changes. The principle of conservation of angular momentum, stating that in the absence of external torques, the total angular momentum remains constant, is a power tool for analyzing and solving problems involving rotating system.
That's all. Thank you.